56% of supply chain leaders cannot scale AI because of their legacy environments. This simulation shows why. A frictionless flow of modern data inevitably drops into the slow, heavy machinery of an analog foundation. Enterprises are pouring capital into generative AI pilots, expecting predictive intelligence. What they actually receive are local, marginal optimizations layered over broken processes. Years ago, I built robotic cells for factory workers handling active explosives. I focused on restorative engineering, using technology to ensure an operator went home safe, rather than simply populating a dashboard. Today, chief information officers face a digital equivalent of that physical risk. They are under intense pressure to deploy AI across global supply chains to capture an advantage. But they are handcuffed to a foundation built for a slower era. Decades of accumulated technical debt now act as a rigid ceiling on enterprise agility. The prevailing failure is the attempt to bolt a dynamic, agentic AI model directly onto a legacy enterprise resource planning system. This strategy ignores a hard truth. The primary choke point for modern enterprise scaling is architectural, not algorithmic. A legacy ERP is a system of record. It is engineered for transactional stability and financial compliance, not real-time, intelligent action. Linear batch processing takes a multivariable transaction and strips away its operational context to fit cleanly into a general ledger. Feed that output into an AI node, and you feed it a shadow of reality. The resulting recommendation is inherently flawed. Advanced AI models run on context. To make complex routing or predictive decisions, they require the exact unstructured, rich data that the ERP just discarded. Operators compensate for this vacuum by building shadow IT. Employees spend hours cross-referencing manual spreadsheets, operating entirely on stale intelligence. For the CIO, this highly customized core system turns every mandatory security upgrade into a massive, high-risk IT project. Custom-coded integrations are brittle. When the legacy system attempts to update, these fragile connections snap, forcing the organization into upgrade paralysis. An AI model starved of context and tethered to a fragile architecture cannot optimize a business. It merely locks in past inefficiencies at a higher compute cost. This brings us to the law of physical parity. An enterprise's digital data topology must match its physical operational topology to remain accurate. Consider the physical reality of urban logistics. Fulfillment networks moving through tight city arteries are highly relational, chaotic, and fluid. Now, look what happens when you map that physical movement onto the rigid, decades-old relational database schema of a monolithic ERP. The physical world does not wait for an API sync. During a batch update, the digital ledger completely loses track of the actual physical inventory. Market shifts and supply chain disruptions happen in milliseconds. Legacy IT cycles require months of engineering to reconfigure basic routing logic. Forcing real-time physical operations to wait for legacy database updates turns enterprise software into a direct operational liability. If the architectural mismatch between advanced AI and legacy systems is this clear, we must ask who actually benefits from keeping it in place. Entrenched legacy software vendors utilize this technical debt as a highly lucrative control point. As illustrated here, these vendors act as gatekeepers. They install digital toll booths, charging enterprises for API access to their own siloed operational data. Vendors rebrand this basic data access as advanced AI functionality, selling an expensive illusion to overwhelmed IT departments. This manufactured obscurity traps critical data inside the monolith, preventing the organization from adopting specialized, best-in-class cloud tools. CIOs hesitate to act because the calculated risk of replacing monolithic software involves immense operational disruption. Buying AI bolt-ons from incumbents avoids the disruption, but it pays a premium to permanently lock the enterprise into the vendor's control point. Competitive asymmetry comes from intelligently bypassing the legacy system, rather than attempting to replace it overnight. The solution is a headless, agentic orchestration layer. Watch how this geometric lattice self-assembles to build a bridge, completely bypassing the static block below. This orchestration layer uses Edge AI to manage real-time physical logistics and inference routing. It directs operations locally without waiting for the ERP to respond. The legacy ERP is relegated to a new role. It becomes a dumb ledger, used strictly for retrospective financial compliance. This transition moves the enterprise from a passive system of record to an active, predictive system of action. The ultimate rule for the modern operator is absolute. Whoever owns the real-time inference routing owns the operation. Stop relying on vendor promises. You can prove this thesis within your own organization by executing a 30-day actionable validation test. The protocol is straightforward. Task a single AI agent with executing a multivariable supply chain rerouting protocol during a simulated disruption. In this split-screen comparison, measure the delay caused by your infrastructure. Track the agent recalculating a route in milliseconds against the legacy database's loading wheel. Isolate that final latency number, looking closely at the delta in processing times between the two systems. That specific latency metric is the exact measurement of your enterprise's operational risk and your competitive disadvantage. True restorative engineering requires systems that move at the speed of physical reality. Anything slower is an expensive illusion.